Okay, so now we have a talk by Raphael Schouten from an ecologist based in Copenhagen,
Copenhagen, yeah.
and
Globe Institute.
Guillaume, uh, who is in EPFL, right? And they'll talk about one possibility to have interfaces in Julia. So take it away.
Okay, I'll get started. So today we're going to talk about interfaces.jl, a way of making interface tests for your objects. So the motivation of this is that Julia has no formal interfaces, and this can lead to a bunch of correctness bugs, famously talked about in this post by Yuri a couple of years ago. And this package was kind of a response to this. And the question is, what can we do about correctness bugs? And can we implement interface testing in a package? Kind of as a way of setting up for doing it in base later and exploring the space. So there are a bunch of packages that have done this so far from different angles, required interfaces, interface specs, duck dispatch, and interfaces.jl. And this is just one possible approach, and by no means the most sophisticated, but it kind of works. So I'll just start by defining what we mean by an interface in interfaces.jl. So it's a set of functions with documented contracts, and it may be tied to an abstract type or not. Think abstract array versus tables.jl. Behavior may be testable at compile time or runtime, so we run runtime tests. And interfaces may have optional components. And for abstract array, setIndex is not implemented for some static arrays types. It's a classic example of this. So I'll go through the approach of interfaces.jl with a simplified abstract set example. So first, we define the interface using the interface macro. We give it a name. Here's set interface, abstract set as the supertype, pass in some components that we'll define in a minute, and a description of the interface for the documentation. So we define mandatory components in a name tuple, and we use this component with a tuple of label and function as the standard syntax. So here we have a tuple with 4 mandatory components, and you can see the last one, in. We have in is true for all elements in the set, a very basic test, and then we have the test after it that tests that for some object. Pretty simple. Then we can define optional components, also for set. And these are things that may be implemented for some types. You can see at the bottom, intersex has multiple tests for one component, so it's kind of extensible in scale. And then we can combine these mandatory and optional components into our overall components object. And of course, you can write this all in line in your tests. It just doesn't fit on the slides, so we have to split it up. Now we've declared interface. We can declare an implementation for a specific type, and here we'll declare it for set. So we have the implements macro with set interface and some optional components, then the type set, and then the test data for set. So we define some test data in the macro so that we can call functions on it later without data. And now we can test the implementation just by calling interfaces.test, set interface and set. And we get this printout back with the passing tests on the objects, and we will get them back red if they failed with a false answer. So it's like an abstraction of testing for arbitrary objects. We can also just call test on the whole interface and test everything in scope at the moment. And that will iterate over all of the objects available. Here we've only got one. We can also check traits, and we can use this as a traits interface. So using the implements method, we can check interfaces.implements, the set interface, set, and that's true. And we can also check the optional components and which ones are implemented and not. And none of this has a runtime cost, so it can be used as a trait. And we can also check extended help, and all these details are available from the definition to read and check the interface. So a bit of a status roadmap on the package. We've got the base interfaces sub-package, which is partly written, but it's a lot of work to define all the base interfaces, and some of them don't have actual documentation yet. So some help would be appreciated with that. And there's a bunch of implementations out there in the ecosystem. Dynamic expressions.jl has implemented it, dimensional data, and the graphs ecosystem has. And on that note, I'll pass over to Guillaume to talk about the graphs ecosystem.
Yeah, so in a nutshell, I was interested in this interfaces.jl package because the Julia Graphs interface is one of the most common ones in the ecosystem, and a graph is not really defined by what it is, but what it can do. And so this is a perfect use case of an interface. So the abstract graph interface, if you go to the Julia Graphs documentation, you'll find a list of methods that you need to implement. But this list of method is provided in natural language. And so here, what I want to do is test them in a formal, rigorous way. So among these methods, some are mandatory, like listing the vertices of a graph, listing the edges of a graph, and some are optional. For instance, not every graph is modifiable, so add vertex bang may not be useful for every type. And the real tests that we want to run is not just whether these methods are defined, because that's easy. We also want to check that they are coherent with one another. So we wrote an automated checker with an intern of mine, Oleg Fafurin. It's called Graphs Interface Checker, and it checks your graph implementation. So there are a few checks that can be done at compile time and that are fairly simple. For instance, the number of vertices of a graph, the function nv, should always return an integer. But as Raphael said, there are some checks that you can only do at runtime. For instance, for a given graph, nvg should be the length of the iterable of vertices. And so that's typically something that you want to test not in the generic abstract way, because both of these methods could be defined, but their coherence could fail. And so thanks to this automated check suite, we have a lighter interpretation burden on the user, and as a whole, a more robust ecosystem, because we used it to actually find some bugs in a few graph implementations in the organization itself. And thank you for your attention. We are happy to take questions.
Okay.
Okay, so what interfaces are already checked with interfaces.jl? Can I check an array interfaces, or what's there already?
At the moment, there's just these packages, dynamic expressions, dimensional data, and the graphs ecosystem. I've started on writing out the base interfaces, but it's quite a lot of work. And some of them aren't actually defined clearly yet. They're defined in unmerged issues. One of them is frames issue for set interface, which I use for the example. So I would really like some help to write all of that out if anyone's interested. But yeah, it's not done yet.
But we could probably already catch some bugs. There's like iteration sets, dicts.
Yeah, there's the dict set, iteration, and array interface, but they're not complete. But they may help. Yeah.
Any other question? Over there, I think there's one. Here.
Over here in the corner.
Hi, thanks for the talk. So I was wondering how this could integrate with maybe some IDE support to like discover what methods I can use with a given type, maybe from another package. Do you think it could tie in with that?
Yeah, maybe. I never thought of that, but it possibly.
It's a bit more difficult because the interface is not really defined in terms of which methods should exist, but rather in terms of a set of functions that return a Boolean. They return true if something is right and false if something is wrong, and so it may be slightly hard to run this all every single time. So what you could check in the IDE is the trait, probably, but checking with each condition individually may not make much sense for the code writer.
Thank you.
On top here?
Over there.
Maybe one last?
Hi, nice talk. I was wondering, since we have like the type system which relies on a hierarchy of abstract types, would it be interesting for the interfaces to do something similar? Because you have now the iterable interface, but also the array interface, but of course that is a superset of the iterable interface. So is there like any support for those things? Or would it be more like trait-based, like?
Yeah, we actually have a PR sitting there for that at the moment, but the idea was to try and do multiple inheritance rather than single inheritance, because actually we're often combining multiple. It works at the moment, but it turns out to be, it's a bit vague with the optional parts of the interfaces. When the inheriting component needs some optional parts and you've originally defined different optional parts, it's not quite clear how to use those together. But it kind of works, but I haven't merged it for that reason. Yeah.
Well, maybe then you should remove optional part from an interface and just say you have a interface base iterable or something, abstract iterable, and then if that's the other methods, you get this multiple inheritance. No.
So we have to move the conversation out
Yeah.
stage, but let's thank Rafael and
Later.
Guillermo.
Thanks.